Hi everybody. Today I would like to give a brief idea about our work that was funded by CNI PhD Fellowship during the year 2021 to 2022. So this is titled Low Latency Replication over Memory Constrained Servers, and this was a joint work with Ajay Patita, Pradeep Sarvipalli and Parmal Parag. So here the question was to find some good storage practices in distributed storage systems, which will help minimize the file download times. And in particular, we are considering memory constrained systems here, which means that we can store only a part of the file, which is to be stored across this system at each of the servers that constitutes the distributed storage system. And whenever there is a request coming in to access this file, it is provided parallel access to all these servers which constitutes this distributed storage system. So in general, in such systems, one simple practice that often helps reduce download time is to replicate the file. So you replicate the file, put these multiple replicas of the file on parallel servers and serve them in parallel, which will help in reducing the download time of the file. And here in particular, we are considering the memory constraint systems. So what we are trying to do is that prior to replication, we chop them into smaller fragments and then we replicate. So here is one example to keep things simple. We restrict ourselves to the discussion of a single file. So suppose there is a single file which is being divided into two equal fragments, A1 and A2, and it is replicated and it is stored across this file. So now whenever a request comes to download this file, it will try to download these replicated fragments in parallel, and whenever it finishes download of any two distinct replicas, then the download is considered to be complete and it can reconstruct back the original file from this replica A1 and A2. All right, let us look at a different example of the same process where we are actually going for a finer subfragmentation. And so here we have a file which is being divided into, say, some 7 pieces, replicated and stored across the server. So now here a major question arises, which was not present in the previous picture. That is, here we have multiple subfragments per server. So now, how exactly should we store these fragments, or how should we distribute this fragment across these servers so as to minimize the file download time? In the previous picture, since we had only one fragment per server and all the servers were identical, it was not important that however we distribute these fragments across the server, since they are served in parallel and since the servers are identical, it will not affect the download time. But that is not the case here. Since we have multiple subfragments, we have to think about how exactly to store these replicas. And another question that comes up in this scenario is that at each server, we can have different fragments stored across it. So in such a setting, how exactly should we access these replicas? That is, for example, at server 1, we have fragments 1, 2, and 3. So which fragment should I serve first? Is it 1, 2, or 3? And which one should I serve second and the third? So these are the two questions which was raised in this work, that is, what is the optimal storage strategy and what is the optimal access sequence in distributed systems with memory constraints and file fragmentation. So here, let me run you through the results that we have come across in this work. So one major point is that when the download times are exponential, we come up with a new metric, which is mean number of useful servers, and maximizing this particular metric will help in minimizing latency. And in this alternate characterization of the problem, that is in terms of maximizing the mean number of useful servers, we propose certain randomized way of storing the replicated fragments, and we show that it is asymptotically optimal. And In non-asymptotic case, we actually come up with some deterministic storage strategies, which is actually shown to have some good latency performances. And coming to finding the optimal access sequence, we show that this is a Markov decision process, and it can be solved using classical methods. And we also come up with some practical algorithms to find good access sequence. All about this work can be found in our publications. There is one ISIT conference publication, and there is a journal publication at Transactions on Information Theory. Please take a look at them if you are interested to know more about this work. And thank you so much for listening. With that, I would like to conclude. Thank you.